It's a pleasure to welcome you all to this YouTube channel on electromagnetics. My name is Samel and I am an associate professor at the Technical University of Denmark, Department of Electrical Engineering. I am teaching a course on fundamental electromagnetics in which we use the book by David Cheng, Field and Wave Electromagnetics. Every time the course runs, we have about 100 students to which we cover the topics on electrostatics, magnetostatics, time-varying fields, plane waves and transmission lines. This channel will include a number of video lectures and video problem tutorials that we have prepared for our course. So let me briefly explain what you can expect in this YouTube channel and also why we have decided to prepare these video lectures and video problems to support our course. Oftentimes, electromagnetics is regarded as perhaps being one of the most difficult subjects in all electrical engineering curriculum. What is sometimes very difficult for students is to link mathematics to physics of a given problem in electromagnetics. This is something we can easily illustrate with these basic charge and current configurations that we have shown over here. And what is difficult from time to time is to figure out the field direction for a given charge or current configuration, and also how the given fields will depend on coordinates. For instance, we will spend substantial efforts on explaining why the field for our point charge over here will be radially directed. That means it will have a radial component, and in particular also why this radial component will only depend on this radial coordinate. When we look at the configuration to the right or similar configurations, we will explain by using fundamental laws why the B field, which is the magnetic flux density, will have only a phi component for this configuration, and why this phi component will only have this radial dependence shown over there. Once you know the fields and how they depend on coordinates, oftentimes the students are confronted by solving integrals of different kinds. We have line integrals as shown here, surface integrals as shown over here, and also many times volume integrations would have to be performed. What is difficult in this regard is also to establish the correct integration limits for a given physical configuration, and in particular to identify the correct DL, DS and DV integration elements in a given coordinate systems. So these are all things that textbooks on electromagnetics would usually claim are easy to see, but experience has shown that it's not really always the case. This is the main purpose why we have decided to prepare these video problem tutorials. In particular, we have prepared 30 video problems, 10 minutes each on average, on different topics in electrostatics, magnetostatics and time-varying fields, plane waves and transmission lines. In particular, we consider problems in which we solved in a very detailed and step-by-step manner fields and potentials from static charges and steady currents. We are also determining capacitances and inductances for capacitors and inductors of a variety of shapes, for which we also calculate stored electric and magnetic energies. We will also consider solutions to Laplace equations in rectangular, circular, cylindrical and spherical coordinate systems, and we have also decided to include selected problems on time-varying fields and Maxwell equations. Furthermore, plane wave reflection and transmission, as well as transmission lines and matching circuits, will also be illustrated in those shorter video problems. To support these video problems, we have prepared 5 longer video lectures on the theoretical aspects behind these video problems, and these will deal with fundamental electromagnetics, core areas such as electrostatics, magnetostatics, time-varying fields, plane waves and transmission lines. All in all, we hope that these video problems and video lectures will facilitate facilitate your learning and understanding of the many interesting aspects of electromagnetics. Thank you very much for your attention.